Thank you. This is our third tutorial of today, and it's being held by our co-organizing partner, Mario Annau. As you can see by the presentation, we'll be talking about creating production-ready Shiny apps for our data science conference, DACH. Mario, feel free to start.
So again, Milos, thanks for the introduction. I'm happy to be here to introduce to be honest, a rather technical topic, which I hope I can spice up a bit with a few more modern tools available, even including ChatGPT. So stay tuned. I hope you enjoyed. I hope also that all of you have received the slide link, and I also have
Let me check that for you.
Posted a link to a GitHub repository where all the code is. So in any case you get lost or something, no worries, just ask questions. You can ask, I guess, via the chat directly, or and I hope also, Milos, you can handle this, because when coding it's always hard to do that. So
if you want, we can send some of those links right now in the chat just to make sure that everyone got them.
Yes, so probably the slide link and also the link to the GitHub repository would be nice, I guess.
Okay, we'll send that later. I'm going to turn off the camera now so you can focus on the presentation.
Okay, great. Thanks, Milos. So creating production-ready Shiny apps is a topic which, comes up from time to time. This talk is really geared for people who already know something about Shiny, but who might have seen some problems deploying Shiny apps, or using those kinds of Shiny apps in production, making them maintainable, having documentation, all those things, because surprisingly, a lot of things can break in that kind of sense. And also, since we are doing some projects, or as part of some projects, we also encountered these issues not only on the small scale, so for like student projects, but really in big corporation setups. So that's why I hope that you find this helpful. And please, if you have any questions, please ask right away, so that you don't forget. Okay, so for the agenda, what I will show is just a short introduction of Shiny, or why Shiny in production is required or is interesting, especially in corporate setups or production setups. What I will do as the main part is basically a code through. So starting from a simple Shiny application, I'll turn that Shiny application in a step-by-step procedure to a nice even package or a deployable Docker container. I make use a lot of the package use this, so that's a kind of a handy tool to deploy or to create this kind of deployable Shiny application or productionized Shiny application. And there's also some other tools or frameworks available, which I just introduce shortly. The most relevant literature for that kind of topic is the Mastering Shiny book. So that's actually let's say, the gold reference, authored by Hadley Wickham. Actually, Hadley is not the main author of Shiny. It's actually Joe Chang, but it seems that Hadley is more keen on writing things. So he's created this nice Mastering Shiny book, which I can highly recommend. And also a book geared towards really productionizing Shiny application. There is something from Colin Fye and other co-authors from, I think, ThinkR, they're called. And they have also introduced a nice framework, which is called Golem. So also, just for you to know, we are now, during that tech talk, we are turning an existing Shiny application into a productionized one. But you could also start right away with the Golem package, which has some add-ons. However, I found it for that kind of presentation not so helpful because the step-by-step approach and the bits and pieces are missing for really understanding what's going on for those kinds of applications. So just a short introduction why productionizing Shiny application is important, can be important, should be done in any case. Hopefully the main takeaway from this tech tutorial is that it's not so hard doing it. And even if you're a data scientist and not a data engineer or whatever, it's also not so hard to do. And it should be also in the responsibility of the data scientist or the app author. So one main thing is, just imagine you start with your Shiny application. You have some code around which works. You have the app locally. However, you need to make the app work on some different server with some most probably a different operating system, mostly Linux. And also you need to make sure that all the package dependencies and everything is just in place for those kinds of, for your application to start. So that's actually the main challenge you need to solve here. The other thing is what I write. So of course, in eliminating, I call them dumb errors, or errors which, can appear because, you had some merge request, you did some refactoring, you forgot maybe to initialize a variable, you did, something like this. And those are those kinds of errors which can be eliminated through some sophisticated checks or code inspections. The other thing is eliminating, of course, semantic errors. So errors which have to do with the application logic or with the app itself, which you can do, for example, through testing. And of course, like any code you should produce or which should be reused by maybe some colleagues of yours, you should facilitate maintenance through a specific structure, which is given. And also you should document, and especially for documentation in this presentation, I will then use ChatGPT, which I found quite helpful. Okay, and yeah, last but not least, those issues which I've already mentioned between different operating systems are also kind of can be problematic, and you need to take care of them. So I'll now just jump right into a vanilla Shiny app. So I basically created here a simple Shiny app, which based on the wizard. The Shiny app is also, this basic Shiny app is also available on GitHub. For each and every step, I will also try and hope not to forget to create a Git commit. So also after the talk, you just can inspect what I've done step by step directly in the GitHub repo. So you can also either just use this repo or just use the new project wizard within RStudio to just create the Shiny app. I'm using R 4.2.1, I think, the most recent RStudio version. So just in case for you to know what I'm using here. So nothing very special, and also not the very latest and greatest. So should be available for download. Okay, so after you've checked it out, hopefully, or you've created your simple Shiny app, I will start now with the first step, which I find very important, not only for Shiny applications, but for our code in general. Also, is also true for Python code actually, but R has a very nice feature, I think, which is an R package. So any kind of code you have, you can turn into a package, which makes it really nicely reusable, and which is often a step many people don't want to do. So they're offended. They say, okay, it's too much work. I hope I can convince you that it's not. And I use here the package use this and even ChatGPT to do that. So let's start. I hope you can also see my screen. I'm making it hopefully a bit bigger so you can see or follow. So what you see here at the very beginning is just a simple Shiny apps, exactly the same Shiny app which comes out of the wizard. So it's basically a UI of this old faithful geyser, the geyser data. It's a site by layout. You can specify the number of bins in the histogram, and then you also have some plot output, which is basically this exact histogram here. So I just run the app for everybody who doesn't know that kind of app, but for sure you know. You see here, if I change the number of bins, also the histogram changes, all good. So that's just the plain vanilla Shiny app. Okay. So now I would like, of course, this is a very simple Shiny app. For more complicated ones, it might be a bit different. But I just stay with this simple app because I hope everybody can reproduce this and has some sense what it does. So how can we turn the app now into a package? So an R package, most importantly, has a directory, which is called R, where all the R code is stored. And it also has a description file. So those are the two things which are most important for any R package. So what I do now, or what you should actually strive for any kind of package, is that you put almost every code which you have in the app into that kind of package. So ideally, you don't leave anything outside of the package, because everything which is outside of the package can't be tested. So what I'm doing now is I'm creating a folder R. And I'm also now basically just copying over here the app into the R folder. Okay. So since it's a package, we don't need this kind of library here, this library command. And we want to now turn everything into a function, ideally. Everything in R, which is a function, can be is covered by code inspection and checks, for example. So what I'm doing here is I'm just renaming here the UI to app UI, and just do here just a dummy function here, which basically includes here this kind of fluid page. Okay. So that's now simply the fluid page wrapped into that kind of app UI function. And the server function is already a function. Actually, we just rename it app server here. And this is now the main functionality of the app. We just, moved it now to the R folder and renamed it to app UI and app server. The other thing I'm doing, however, running the Shiny app still happens outside. So I just wanted to make sure that all of the code, or most of the code, is inside the package. So the Shiny app is not run within the package. However, so now but instead it should be run outside of the package. So basically what I'm missing here is still actually the importing the package, but actually the app should now be defined through app UI. Here I need to execute to call the function to get the fluid page, and I also pass the app server. So this is now just everything inside the package and just calling everything from the package. Okay, so that now I've put all of my code into the R folder. Nice. However, the other thing which is now missing is the description file. So the description file gives a clear information about the package, who is the author, what's the name of the package, what's the package doing, and most importantly, what is the package importing? So what kind of other dependencies does the package have? I'm using now the use this package, which is, I think, extremely handy to add those kinds of items. So I'm now using use description. By default, the use description function uses the folder name as a package name. In my case now, the folder is named completely differently with underscores and so on, which doesn't work. So I will now use the parameter check name false, which ensures, which basically now creates the description file, but it leaves the package name with exactly this folder name. So I just need to rename this. In most cases, you should basically call the folder name exactly like the package name, then you don't have that kind of issue. I call the package shiny prod, just for no special, I don't know. Yeah, I'm very bad at naming. So if you have any suggestions, please write it to the chat. The title is just a productionized shiny application demo for DSC DACH 2023. The version is fine. Person, it's just me. Also with email address. That's Quantargo. So this is actually always needed for every R package. So who can I complain to? So if there exists some issue, who can I write? And also for CRAN, if you have already submitted packages to CRAN, then as a CRAN author, you also get maybe some emails if something is wrong with your package. Then you also need some package description. I have no clear idea. So later we could also generate it through ChatGPT if you want. The license is actually something important. So most people, if you come from open source, you typically use maybe a GPL or MIT license. However, for production packages or production code within companies, most probably that kind of code is proprietary. So there's again a very nice function, use this if you just look for license. So you can, for example, just inject some licenses you want to use for your package. We are using now the proprietary license, and you can enter here the copyright owner. So that would most probably be the company name. I just call it now Quantargo GmbH, which is the name of our company. Okay, and it's done. And it just changed now the license to file license. And it has also added a license file here, which tells, okay, copyright 2023 Quantargo, all rights reserved. So this is now, let's say, by definition, a proprietary license, and the package is now not open source anymore, which might be important for in company settings. Okay, so we are mostly done here, I guess. So encoding, UTF, Roxygen is also used for documentation later. And maybe you need to restart here because RStudio just recognizes a package if there's some description file around. So maybe you need to now close RStudio and reopen. But in my case, it's already, this build tab is already there because I had some I worked on some package already before. That's why. But if not, just close and open. And if there's a description file in the project folder, then you should also see the build tab here. Okay, so that's actually it. So we can now say we have now, let's say, something like an R package. Of course, it's a very rudimentary. It misses maybe a few things, but yeah, we can call it an R package. The only thing which we are now missing, which is also crucial here, is in a way, this kind of app file, app.r, is still our main entry point to the app. So of course, we have now put everything into this kind of R folder and have added a description file. So the app.r is now within a package, but we need to load that kind of package directly within that folder. So when Shiny loads that kind of app, it basically has to load the app through the package. And there's a very nice function here, and a very fundamental function, which is it's called package load. So the package is called package load. And with this package and the load all function here, I can basically load the current package, which I'm currently in, the Shiny prod package, directly into the R interpreter. So this basically solves the problem, even if you have deployed it maybe also to RS Connect or some other server. You can directly load the app as if it was in package. So this is this kind of duality. It's still an a Shiny app, but the Shiny app is now loaded through this kind of package. So all of the functions are within the package. So if I'm using this, what you see here is that it's loading the Shiny prod package. So immediately I've now loaded the Shiny app as a package directly into my environment. And you should also see here that it's now indeed loaded in the global environment. Okay. So let's see if this works. I'm not sure. Maybe we're missing something, but voila, it works. We have now the app created within a Shiny package, which is, you might say now, nice. Okay, why did I have to do this? That doesn't make any sense, but I will show you why that's important in a minute. But just to be sure, I hope everybody, so if you have any questions, please ask them right away in the chat if something's not clear or if I've missed something. So if there are not any more questions, I just continue. Okay, so what we've done now so far is we've gone from a very basic Shiny app. We've put the app, so the UI and the app server. Of course, if the app is more complex, you might have many more functions into the R folder. So this is called now app.r. We have now created those two functions, which is nice. And we're now loading the whole package through load all and using the functions through Shiny app. Okay, so far so good, but why have we done this now? The reason is that since it's now a package, and again, maybe you have to reload RStudio here. Since it's now a package, we have now this nice build tab. The build tab is important because it has a few nice functionalities. So most importantly, we can run now package checks. A package check ensures that everything, every function, everything which is within a VR package is checked in the sense that there are no variables used which are not instantiated. It makes sure that it runs on most OSs, ensures encodings, all that kind of stuff. And most importantly, for users of the package and for maintenance, it ensures that all of the exported functions in the app are actually documented. So everything which we have here, so app UI and app server should be exported functions, should also be documented. So that's actually very important and helpful for later users. So how can we do this? One thing which we've not done so far is we haven't used Roxygen now. So Roxygen is a very nice tool which gives you inline documentation. So you can add documentation above each function. And that way it generates all the R man pages and manual files. So maybe you need to set here or install before Roxygen and then set here the check mark, generate documentation with Roxygen. And I also always have this check mark at install and restart. So whenever I'm installing and restarting, Roxygen should generate a new documentation. I'm also trying to run here document, which works here. And it also creates a namespace file. A namespace file is important for every package because it defines which functions are imported from which other packages and which functions are actually exported. So if I'm now reloading this, I'm running Shiny app. Okay, that still works because the functions might already be defined in the global environment. Not sure. If I'm reloading, okay, it's still working. However, it's not exported directly within the namespace file. So again, every function here, the app UI, for example, should actually be exported. So what I'm using here is a Roxygen documentation with hashtag and a single quote. And I'm using export here. So I'm really telling Roxygen that this function should be exported in the package namespace here. So I'm adding those two just above those two functions. And whenever I now use build document, it should now rebuild the namespace file and now export those two functions again through the namespace, through the package namespace. And actually then, I don't know, maybe has to do with I need to reload, but only then that those functions are really available through the load all function. Okay, so now we have exported them explicitly. And what I now will run is just the first time a package check. So let's see what the standardized package check now gives me for this specific Shiny app. So, okay, I'm going from top down. So it gives me non-standard files directories found at the top level. So for some reason, the project folder is just is already within is also compiled into the package. So again, here I can use this and use the use build ignore. So this tells then the R command build step to not include specific files. And for example, I'm using here the app.r. So exactly those two files, basically. Of course, you could also use wildcards. I'm just excluding them explicitly. So what it has done now, it has created a new file r-build-ignore, which here tells our command build to not include exactly those two files. So this should hopefully, we can get rid of this error here. Okay, then we have a few missing imports. So in any case, if you have a package, you need to tell, you need to explicitly specify where all those functions are coming from. This is, in my opinion, a very important step, because since R has not such an explicit namespace system like Python, for example, it makes a lot of sense to have this package and this explicit definition of functions. Okay, and then last but not least, we have undocumented code objects. So this tells me, okay, I'm missing here a few actually documentation for the app server and the app UI function. And now, since we're lazy and the tech talk shouldn't take too long, I'll now use ChatGPT to hopefully get rid of most of these errors. Of course, if you're not allowed to use ChatGPT within your company or your environment, please don't. However, for the sake of this talk, I'm using it now. So what I'm doing now is I guess many of you have heard of it. So ChatGPT is just the latest and greatest, not the latest and greatest, but in this case, it's, I think, the 3.5 large language model released by OpenAI, which was already covered in the media everywhere. I guess I am not introducing it too much. And I just want to show how it can help to, for example, in this case, document this app UI function. So this has now just this defined UI application that draws a histogram. But I would like to ask ChatGPT. I can also even tell it, okay, you are an Roxygen 2 documentation generator. So I even scope it here into what it is, but you don't even have to do this. And then I tell it, okay, create a document the following function. I just paste in here the function code. So I guess, and now what you see here is basically ChatGPT is here creating the documentation object. So it tells, okay, the app UI function creates the user interface for an application that generates a histogram of old faithful geyser data. And it returns a fluid page. It imports a bunch of things. Those are the imports we are needing here. We really need to get rid of the errors. It exports it. Yeah, that's actually fine. So we can just copy it over if we're satisfied. It actually even, it also included here the app itself, the code, but actually we're satisfied here. However, what I'm missing maybe is a simple example. Yeah, no, let's leave that. But in some cases, it also makes sense to have an example. Okay, so those kinds of imports, which might be missing here, which you see here, are now also created here by ChatGPT. So I don't even have to do this. Okay, I'm now, let's do the same for the app server. Create an Roxy Gen 2 documentation for the following function. So I'm now not even scoping it down before, but I guess it should also work. It might be, if you retry that yourself, that ChatGPT just generates different code. So that could be because there's some variance in the model and depending on the exact query, but also just if you just try it over and over again, it might be that the output is different. So for example, here, it also nicely generated a nice example here. Of course, we should always reflect what we're getting here. So this function takes two arguments, input and output, and creates server logic for a Shiny app. It generates histogram plot, blah, blah, blah. So fine, I take it. Okay. And that's basically it. We've now just added here to, or documented here, the app UI and the app server. It even has an example here. In our case, we don't want to run it. But for anybody who has had to create those kinds of documentation objects and to rightly complain that that's a lot of work. So using tools like that, actually, there's no excuse anymore for not doing it, in my opinion. So, so creating those kinds of documentation works quite well, I guess, with those tools. I just don't want to run the example here. So I run check again. So now we have updated our documentation. So just for your information, documentation is here in the man folder. Oh, we have an error. Okay, so we're missing here Shiny in the imports field. So since we're now importing from Shiny a bunch of functions, we should also include Shiny or import Shiny in the description file. Okay, so let's check again. no T. Okay, I tried. Could you also please consider equivalent things in Python parallel whenever it's possible? So yes, as some of you might have heard, Python is also now, so Shiny is also available for Python, or there are also other dashboard frameworks, including Streamlit or Dash, for example. For Python, what I've seen is that the pattern, just creating a package out of a simple application, makes a lot of sense. It really depends here. If you're just keen on having or fixing the package dependencies, it might be sufficient to have just a venv. But also for Python, if it's a bigger application, a bigger dashboard, it makes sense to have it within some kind of package context. I'm just a big fan of it because it's just an agreed structure and standard you set for any kind of code, either in R or in Python. So if you have that kind of structure already in place, anybody, any developer who might not be so into your application yet has already a nice overview and knows how to deal with it. And most importantly, that's also true for Python. You get all the, the nice things out of it. You can put it to a package repository. It generates documentation, all those kinds of things. Okay. So now we are still having a problem with the faithful. So faithful here is a data set, which is in the datasets package. Most typically, and this didn't work when I tried it out for some reason, I'm not sure why. Yes, you can mix R and Python code if it's an R Shiny app through Reticulate, if it's a Python app through RPy2, I guess. So please correct me if I'm wrong. But yes, you can mix easily. So within R, you would use Reticulate. So you can have a PyTorch model within the R Shiny app, for example. Just need to watch the memory. So what I'm just using here is, or again, I can use this. And then I just import here from the package datasets, for example, faithful. This would add now a package documentation, a package level documentation. Most typically, I do this just because I'm lazy. In this case, and it gives me an error. Yes, so that's something for the data set, an issue which I just encountered. So in that case, it doesn't work, unfortunately. What I'm just doing here, since the datasets package is just a standard package which is available within R, I'm just using here the datasets namespace prefix. So again, this is not high. Most typically, you should use an import from. In my case, this didn't work out. Maybe if you find out why, please let me know. Okay. So I hope I've now made R command check happy. So let's see, but you can never be sure. And why I'm stressing this, and this is actually exactly the reason why I'm using a package here, it gives you a lot of standard tests, which are proved or battle tested by the R community for over 20,000 packages. So it makes a lot of sense to use those predefined checks in any case, every time when possible. Okay, so, and I would also stress here, so now we have a successful R command check. So we don't have any errors, any warnings, or any notes. That's great. I would also just urge you to go for exactly this. So some people then think, okay, it's just a warning or it's just a note, so I don't have to care so much about it. What I think is why it's even important to get rid of the notes is because, for example, if you have some uninitialized variables, which you might have introduced by accident or where you're using names by accident, you run into the problem that you only get a note, and this kind of note is actually highly important. So that's actually why you should always go for 0, 0, 0. No notes, no warnings, no errors. Okay. So that was for the package check. What I'm doing now is, since we have now successfully turned the Shiny app into a package, now I'm just committing it. So if you want to rewatch or check the code, just use GitHub. You could also create, I've seen you can also create now commit messages through GPT or Codex or GitHub Copilot. So anyways, I'm just pushing. Okay. So I'm just creating those kinds of checkpoints. So now we have a package, and now we are already in a very good place. So this is really the main difference for most of the Shiny or most of the code. Those are the steps you need to do. Those are not highly, how should I say, very complicated steps, I think, especially if you do that just at the beginning of your project. If you're doing it on a later stage, that might be a bit more of a problem. But as you've seen, there are a few helpers around, like use this and even GitHub Copilot. So there's even some tools around which can help you. Just going back to the presentation. Sorry. Okay. So that step is done. Let's go to, we've also finished this step. So we've used dev tools to check the package, which we've now successfully finished. And now comes something which is also kind of new in the R community, also discussed a lot, loved and hated a lot, but I will still introduce it because it's so important. And it's called renv. So for those of you who haven't heard about renv, R is a package, how should you say, manager, which can be used to basically nail down all of the packages and also the package versions you've used. So most typically, if you're using a package or if you're within some environment, you most probably have just the package versions which by the time when you installed them were available through CRAN. However, there's, especially in production settings, it's extremely important to really nail down the exact package version and also the location where the package is coming from. For many different reasons, maybe the packages have been updated, maybe there is some bug occurring then only for some specific package dependency. So lots of different things. And RENV is now really also the official replacement, the stale replacement of PackRed. So for all newer projects, you should actually use RENV. Another nicety of RENV is especially the package installation and especially for continuous integration setups. So RENV is basically for in any, it doesn't matter if you're on Mac, Windows or Linux, it always creates a package cache, which is used and reused by RENV for each and every project. So that way you're not forced to use always the same package versions of, I don't know, dplyr, ggplot, whatever, in every package, in every project. But actually you can switch versions from project to project. And those packages which are used in every project are only symlinked or linked to the project. So you're also saving disk space that way. And of course, in continuous integration, you can reuse the cache for further deployments. So for any other deployment which you're using afterwards, RENV just makes sure that the packages are just available and don't need to be compiled and installed all the time. Okay, so that was my advertisement for RENV. Please, if you can use it, how can you use it? Basically, for any existing project, within the project, you can run the command RENV init. So RENV init basically checks your project, checks all the files, sees what kind of packages you're using, what kind of packages you're currently using, and then also creates reinitialize the project within. So I'm reinitializing the library. Have used it here before. Okay, and now what it's done is it has scanned the project and it has also created a new folder RENV. And this RENV folder is also used to then cache some packages. And most importantly for you, so for the developers, you create this kind of log file. So JavaScript developers might know this from maybe NPM or something. But here you also see, okay, what kind of repository am I using? What packages? So for example, the R6 package was version 251. It came from CRAN and it had some specific hashes. So those hashes are used by RENV to identify the packages. But that way, and also it creates this kind of profile. It also activates the project. And if you just now give this, and of course commit, but if you now give this project to one of your colleagues and the colleague uses RENV activate through our profile, which is by default there, then you make sure that hopefully, not always, there might be some issues, you can reuse and use exactly the same package setup, even on another machine, even on another operating system. So this is, I think, very helpful. And again, in addition to the package we created here, you should also create this kind of rn package log file. For Python, there's, for example, some similar stuff, venv, for example. And actually, Python has many more options here. For some, I don't know, there's not such a clear tendency for one single solution. Okay, but here I'm actually already fine. I've now created rn. I'm committing. Or structure. Okay. Also pushing if you want to just use it right now. Okay. Okay, so far so good. So what we've done so far is we've created the package. The package is exactly specifying what other packages we are using. So datasets and Shiny. In that case, just interesting why datasets is now here. It also specifies through the namespace exactly what functions we are importing and what functions we are exporting. So this is really now a proper package. And on top of that, we're even using rn, where rn really specifies exactly what package versions we're using. So that way we can be not 100% sure, there's no 100% encoding, unfortunately, but we can be very sure that this should work out and that somebody who reuses it, and also, of course, if it's deployed, this somebody might be also a server, that exactly the same package versions are used here. So that was through rn init here. Okay. Now, a highly debated topic, test cases. Test cases are, of course, I cannot, make more advertisement for anything else than test cases. They're so important, and make sure that your project or your app just survives all the hard weather and all the refactorings and merges and whatever. So test cases are really important for your project and should be added in any case. So since we're now using a Shiny app, there's also, or some of you might know, there's also a Shiny test framework or package, which also lets you dynamically test the Shiny app, so the user interface. I personally am not such a big fan of this, or generally it's hard for any web application, you might know, to do those kinds of user interface integration tests. It's always kind of hard, also hard to define, okay, when it's ready, when not. Your test time just explodes, and you need to really make sure that it works, or that you don't get any false positives or test failures, although it works all. So very hard thing. I would, for you, so if you add test cases, you're better than, I guess, 98% of all the other R projects or Shiny apps around. What I would recommend for you most of the time, was not always, but just what I've seen so far, is try to separate the user interface with the actual application logic. That's a very basic computer science, maybe inspired view. but at least try to have great test cases for the application logic. Since it's now a package, you can even then reuse the package without using the Shiny app. So that's then also possible. But at least your application logic is should be then pretty solid, and you should be pretty confident that it works out. In our case here, I would, so our app is not doing a lot, to be honest. So it's only creating this, this histogram here based on this standard data set. So of course, again, I could use ChatGPT to create a function, but just for the sake of, still being a human, I create now, I try to turn this application, this logic, which is actually here using those reactive components and which is somehow baked into the app. I try to just create a new function out of it. I just call the function create histogram. So I'm doing it inline and just copying it later too. So create histogram, what would be a nice function? I just have a vector, in this case, datasets faithful. It's just some vector as you see, so I'm calling it X. And then I also can specify the number of bins. So let's call it bins. And this is now my, okay, so X is specified before. I'm now just putting here, okay, so it's actually N, let's call it N bins. So, okay, naming is hard, especially for me. So N bins here, so the number of bins we're using here. So let's call it N bins here is just this. And I'm just replacing now bins like this. And of course, here we create the histogram. So the histogram is based on X. The breaks are now the bins. It's dark gray. Of course, we can also create, I don't know, in different colors or parameterize the colors, but just for the sake of, having a histogram here. And this is now a function which we can easily extract. So we can call it from here. So we just use here. Okay, that's even not necessary here. We just use here and this and the number of input bins. Okay. Okay, and now this is just calling the function, which should do the rest. I'm just now copying the function over just to see, for you to see, okay, this can now be a completely separate function, separated from the UI and the application. We call it create histogram. And so this is now just really an external application, which you can even use without Shiny. Okay, it might be that I've forgotten something, but let's have a try. So again, I'm loading everything again and running the Shiny app. For some reason, HTML tools is loaded, but a new one is required. You can use, even if you have activated REnv, you can still use install packages. It should give you then, okay, now it's the new version. Okay, let's try to restart. Okay. Okay, and it still seems to work. Let's change a few bins. Okay, it looks good actually. Okay, the app is still working. That's important. So at least what I've seen so far. We've now extracted the application logic here. Oh, okay. So the application logic is now this histogram, create histogram function. And now we would like to add two things. Actually, since it's a function which we want to reuse, maybe even outside of the package, we want to export. And maybe, as you've seen before, since it's an exported function which should be used outside, it also needs to be documented. So okay, now I'm missing my ChatGPT window. Maybe I find it somewhere. Okay. So I just started new chat. You are our code documenter. Use Roxygen2 to document the following function. So this is something we've seen also before. So now we just get a nice documentation, which gives me the parameter documentation, what it returns, and even examples. So those examples, just by looking at them, should work. So let's use this. Okay. So, and okay, I'm just stopping now. Okay, R crashed. I'm just loading now everything in, and the create histogram function should now also be available since it's now exported through the Shiny prod package. So now we've really extracted the application logic, created that kind of function here, and it even created those examples here. So you see even the examples are working. So this is, and I have to say, ChatGPT here is damn good. I think the text here it generated, it's concise, it's good. It documented all the parameters, everything, and also what I'm always preaching. It also generated examples, usable examples, which you can just use from the documentation. So you just have this histogram. Should have the documentation object. Have I written it correctly? Not sure. Maybe the help page is not updated yet. Sure. Okay, now it works. Okay, now we have this nice documentation here. Of course, out of the documentation, you can create then the PDF manual. So everything, once it's a package, everything, all of those kinds of things are included. Okay, but actually we wanted to create test cases, right? So, so what I wanted to show you where I think ChatGPT is very helpful, because that's a tedious task and maybe it's boring. It has all the things you don't want to do. And also lots of test cases are maybe even not really helpful. So I just tell ChatGPT, you are an R test case generator. Create, let's go with 5 test cases for the following function, right? So I'm just copying the function in, which is here, create histogram. Oh, okay. If that happens, then all the coding is done. Maybe I just no, that can't be it. Okay, for some reason that didn't work, which is a pity because it worked really well. Maybe I have it in the history documentation. Maybe I find it in the chat history. Documentation for UI. Okay, maybe I try it once again. Should I just refresh the page? That's actually a good idea. Maybe I find it again. Use create 5 test cases for the following function. Okay. And now it seems to generate test cases. Actually, this is not what I wanted because I'm using here, I want to use, let's say, test that. So test that is just a different framework, so I'm just stopping to generate here. So test that is a test framework, which is also kind of popular in R. You can use it within the package, just again, using use test that. So that way you're telling the package to use the test framework. So this is just an empty test framework here, but it just created here all those files. So what I'm now telling ChatGPT that say create 5 test cases for the following function using the test that framework. Let's call it this. Sure. Okay. So it's now creating, what have I written? 5 test cases for my function. Let's see how this works out. So the first test case actually just makes sure that it inherits from a histogram object, which kind of makes sense. The second one expects a warning if you're putting an invalid number of breaks in here. Yeah, because X is an empty vector. Actually, this also makes sense. Just by looking at it. Here, we're just putting in a character vector where it's an invalid argument, okay? Okay, again, X is 100 and we have minus 10 bins. So it's an invalid number of breaks. And then we have X is 100 numbers, and we have 10.5 number of bins, which is of course also not. So those are actually very good test cases, which I couldn't have shown in just such a short time period. So I kind of like this. Of course, it could have also checked maybe for other things, but I mean, the function is so short. Basically, you're mostly just testing the hist function here, but it makes sense. So let's use this test. So we use test here. So we create here a new test file, like test create histogram, it's called now. And we are copying over the library test that is actually not needed here. That's mostly for interactive because it's already loaded within the tested file here. But here I'm just copying over all the test cases here. Within our studio, I can now just use where is the test file? Test, yeah. Okay. Okay, they failed. Okay, not all of them are working. Okay, just created a... So only one is working. So that's actually now just overlooking and then really checking what's going on. Length out must be a non-negative number. Yeah, so this is already wrong. So the warning is, well, actually it's an error, it's no warning. So some of the test cases actually didn't work out as I expected, which is interesting. Okay, but again, for the last time so here we don't have any unexpected number of breaks. So, I mean, you can see it both ways. The way it generated the test cases, it actually doesn't work like this. What you could do, or what I sometimes do is I see it as an inspiration just to write exactly those kinds of, or create those kinds of warnings, just in case you, or just for other users to use it properly, because actually the test really makes sense. But the hist function in that case doesn't throw that kinds of errors. So some of them are not correct. So I really need to check which one is now working and which is not. Let's keep at least one then. So I'm sorry for this example. The last time, again, it worked quite well. For 3 test cases, we could, of course, also just, this should work now. Yeah, so the first one worked. Of course, if you want to play around, you could generate a few more or less, I don't know, and just see how this works. So this now works. Maybe we just create a few more. Okay, expect no error, which is a bit nonsensical, but okay. Okay, let's add a few more. But I hope you can see, or at least get the impression that creating test cases is also not so hard anymore. In that case, okay, it didn't work out, to be honest, just from the spot. But if you might also change the prompt or do a few other tweaks, you might get a bit better, well, a few better results. So in my opinion, that makes a lot of sense and should be done more often, hopefully. Okay, but what we've now done or hopefully seen is how to create test cases, how to extract the application or the core application, the core functionality from the app and put it into a new function and even add test cases for that kind of function. So now at least, I guess, we have now tests for the most important parts of the application. So that was for test that. Then there's also a part which looking at the time, I won't show in full detail. You can use CI/CD, so continuous integration, which means depending on the branch you're in, you can just check and build the package or build the app and deploy it maybe to some cluster or to some production Shiny server. So this should, in my opinion, always be done. It's just automating all those kinds of deployments which nobody wants to do manually. So in any case, if you're hesitating, please, this is also not such a big deal and can be done maybe in just a few or just an hour, and it saves you many, many more hours of work. And especially your colleagues who maybe also want to collaborate. So what I'm doing now is adding CI/CD. So maybe add another checkpoint here. So now add test cases. So adding CI/CD, since I'm using GitHub here, I can also use this action. I can use a GitHub action here. I'm using GitHub actions. Oh, I need a name. Shiny prod. Okay. So this now created a GitHub action, just a standard GitHub action. Hopefully, not sure. GitHub API error not found. Huh. Maybe I miss. Content exhaustion. Not sure what's wrong here. That worked actually. Okay, just for the sake of time, I also have prepared here a next branch. And try to go from there. Please move on. Huh? Okay. So I'm checking out next. Yeah. So the next branch is just this, actually mostly the same project, just prepared for this presentation. I'm just showing you maybe now the most important parts. For GitHub projects, what you will end up with, it is this kind of workflow file. So the workflow file basically tells you, okay, I'm using Ubuntu latest. So, which is Jammy, I guess. Checking out the repository. I'm setting up R, installing R. I check the R package. I want to have an error on node, on each node. And yeah, afterwards, I also cache the package. So I really make use of renv. So the next time I run the CI/CD pipeline, everything runs just within a few seconds to install the packages. So this is kind of handy. And again, it's really here a nice package check. Maybe for some of you, you want to also add some different stages and also want to deploy then the Shiny app directly to some server or build a Docker container and do those kinds of things. So this can also be done. And the file, again, has been mostly generated through use GitHub action. So through this use this function. But of course, there's always some fiddling around. Maybe you need to adjust a few things. But this is basically it, exactly this YAML file, which specifies the workflow. And where you then basically get all the checks for free. So everything else is then automated and checked. So this is for CI/CD, again, highly recommended in production setups, especially for checking and deploying stuff. The other thing which we're missing as a final piece here is most of the time, especially if you're having Kubernetes, if you have some cloud setup, like, I don't know, Fargate or Google containers or whatever. Just if you need to have some Docker container in place and, you know, just to run the Shiny app, you can, of course, then also package everything you see here, the entire package here, into a single Docker container. I'm just showing here how this Docker container looks like or might look like. So it's using here Rocker Shiny. It's just removing everything from, so it's removing the initial, just the default apps. It's copying the entire folder you see here to the Shiny server folder. Just for speed, what I've did here is I'm using renv, this override here, which is on Linux systems very handy to speed up package installation, since all of those packages are pre-compiled for exactly this specific Ubuntu version, which is focal here, and just works and is way faster. And here I'm basically just installing renv and restoring renv here. And that's pretty much it. So this Docker file should then work out. I'm also having here, have it here locally as a demo, so you can just run the Docker container. I'm using a Mac, so I need to start Docker first. On Windows, of course, you might also need this. On Linux, it should work out of the box. And maybe it's already up. Okay, now what I've done is I started the Docker container. I used Docker run here. It's exposing here this specific port, which of course you can also change. And just showing here how this app looks like. So I'm using here localhost. The very first start, it's even, yeah, it's activating renv. Can also be a bit optimized, but yeah, for the time being, it's fine. And you see here exactly the app we've seen before, now running within a Docker container and deployable to any kinds of services you can imagine. So now within that container, it should be easy to put it to any kinds of service you can imagine. So I'm a bit over time. I hope you kind of you found the presentation interesting. If you have any more questions, please let me know. Or of course, if something comes up, please just hit me or just write me an email. That's fine. The materials again are everything. The slides are here. What I will do now is I'm just using, so the next branch, which I've previously tried, is mostly the same like we did during the presentation. So I'm just resetting here to next. To next. And I'm pushing to main. So everything which we've done so far is now on GitHub, on the Quantargo Shiny production. You can also leave issues or write me an email. If there are not any more questions, again, thank you and see you tomorrow.